Okay, this video is an extension of Skill 39. So in the last video, you learned how to solve some trig equations. And now what we're going to do is solve more trig equations, but sometimes you may have to factor before you do so. So what we're going to do is we're going to talk about some common factoring that you would do. If I look at this first expression, I see 4 sine squared theta minus 1. Now this is analogous to saying something like 4x squared minus 1. And hopefully you remember that when you have something like this, it's called a difference of squares. And so we're going to factor by making our two groups. You would take the square root of 4x squared. You'd have 2x plus 1, 2x minus 1. Well, the only difference here is that instead of just saying x, we're going to have sine. So I'm going to write 2 sine theta plus 1, 2 sine theta minus 1. Next one, same idea. So we have sine squared minus cosine squared. So that's just like saying x squared minus y squared. So that'll factor as x plus y, x minus y. In this case, sine theta plus cosine theta, and sine theta minus cosine theta. The next one, you'll notice that both terms have a cosine in common, so let's factor that out. Factoring out the cosine theta gives me sine squared theta minus 4. That will end up being cosine squared theta. And once you see that, then you'll notice that we have a difference of squares. Leave our first factor as it is. Square root of sine squared is sine theta. Square root of 4 cosine squared is 2 cosine theta. And that's how you would factor it. For the next one, for this one, we're going to think of this like it was x squared minus 2x minus 15. So we're looking for two numbers that multiply to negative 15, but add to negative 2. So that would be negative 5 and 3. Since this is just an x squared in the front, we're allowed to factor this with our shortcut. So normally you'd write x minus 5, x plus 3. In this case, we're going to write sine theta minus 5 and sine theta plus 3. For the next one, think of this like 4x squared plus x minus 3. This time our a times our c gives us negative 12. And our b is 1, so we're looking at negative 3 and positive 4. You could reverse those around if you needed to. Since this time we don't lead with just an x squared, we have to write out all the terms. So we're going to have 4 tangent squared theta plus 4 tangent theta minus 3 tangent theta. By the way, tangent theta is like that middle x. And then minus 3. And hopefully you remember that when you have 4 terms, you factor by grouping. First group has 4 tangent theta in common with just tangent theta plus 1 left over. You have a minus in the middle and then a 3. And that's going to leave us with tangent theta plus 1 left over. So my factors are tangent theta plus 1 and 4 tangent theta minus 3. Okay. Next one, this is a lot like doing x to the 4th plus 2x squared plus 1. Since this first exponent is double the second exponent, we're allowed to do this with the tree. Two numbers that multiply to 1 and add to 2 are just 1 and 1. And since this is a shortcut, we would write this as cosine squared theta plus 1 times cosine squared theta plus 1 again. Now you could write this as cosine squared theta plus 1 squared. Okay, so we're going to look at how we can do these in our next problems. So this next one, we're doing this without graphing calculator, so we're going to use our unit circle knowledge, and we're going from 0 to 2 pi, so that means radian mode. Okay, first we got a 0 out one side, so I'm going to subtract sine squared theta and subtract 1. And looking at this, I can factor with my tree, so what multiplies to -2 and adds to -1? Well, it's -2 and +1. So 2 sine squared theta minus 2 sine theta plus 1 sine theta minus 1. And we factor by grouping. First group, I have 2 sine theta in common, so I have sine theta minus 1 left over. Second group just has 1 in common, and I'll have sine theta minus 1 left over. My factors are sine theta minus 1 and 2 sine theta plus 1. I set each one of these equal to 0, so that gives me sine theta equals 1 and sine theta equals -1/2. Using what I know from the unit circle, for sine to be equal to 1, so that means our y coordinates equal to 1, that can only happen, yes, that can only happen up here. So that's happening at pi halves. When I look at the other one, I need to think of the y coordinate being -1/2. So that is going to happen in quadrants 3 and 4. So y coordinates are negative in quadrants 3 and 4. In quadrant 3, this happens at 4 pi thirds. And in quadrant 4, that happens at 5 pi thirds. Again, this is just unit circle knowledge. We're skipping this one. We don't know how to write sine 2 theta. Well, you all don't right now. Next one, we're going to rewrite this as tangent squared theta plus tangent theta. So I'm adding tangent theta to both sides, and then I'm going to subtract 2 to 0 at that side. And when I look at this, this is something I can factor, so it multiplies to 2 and adds to 1. Well, let's see. That would be 2 and, okay, hold on. So what multiplies to 2 adds to 1? Whoops, I put plus 2. I was like, wait a minute, something doesn't seem right. That should have been -2, sorry. So we wanted to multiply -2 and add to 1. So that would be 2 and -1. Okay, so sorry about that. So this will factor as tangent theta plus 2, tangent theta minus 1. And now what we're going to do is set each one of these equal to 0. So tangent theta equals -2, tangent theta equals 1. Well, for tangent theta equals -2, we're looking at quadrants 2 and 4. And we can't use the unit circle for this, so I'm going to use my calculator. So inverse tangent of -2. So if we use our calculator, I got to grab mine here real quick. So remember, be in radian mode when you're doing this because we're talking about radians. So inverse tangent, -2. Calculator gives me -1.107. So that's going to be this gap here. I need to add 6.28, which is 2 pi, to get my coterminal angle, which makes this 5.173. Now remember, this reference angle here is also 1.107, so if I take pi, or 3.14, minus 1.107, I get 2.033. Those are going to be my angles for that one. Now for this one, in order for tangent to equal 1, that means sine over cosine has to equal 1, which means that we're looking at coordinate values that are the same coordinates. So if we think about our unit circle, we know that we get positive 1 in quadrants 1 and 3. And it happens at the radical 2 over 2's, or when they're both negatives. Okay, so this is pi fourths, and this one is 5 pi fourths. Okay, so those are going to be our solutions for that problem. Oops. The last one here, we're going to have to solve this one using the quadratic formula. So quadratic formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a. So I'm going to distribute here. So I get cotangent squared theta plus 3 cotangent theta. And I want to make this side 0, so I'm going to go ahead and subtract 1 so that it equals 0. So this one, a is 1, b is 3, c is negative 1. We're going to plug those into the formula, and we're going to say cotangent theta equals, and then we're just going to plug these in. So the opposite of b, so negative 3 plus or minus b squared, so 3 squared is 9, a is 1, c is negative 1. So that gives us negative 3 plus or minus square root of, let's see, I have 2 minus signs here, so I'll have a plus, so 9 plus 4. Alright, so that's going to give us 2 solutions. I'm going to use my calculator and do negative 3 plus square root of 13. And then divide that by 2. We're going to get 0.303. Oops. And then I'm going to do negative 3 minus square root of 13. Divided by 2, and I get negative 3.303. So that means cotangent theta equals each of those. Well, let's think about these as tangents. So tangent theta, so if I want the theta for this one, I'm going to do tangent inverse of 1 divided by 0.303. And for this one, same idea, tangent inverse of 1 divided by negative 3.303. So let's go ahead and do these on our calculators. This one gives me 1.277. That's going to be in my first quadrant. So the other time that we can have that is in the third quadrant. So that's going to be 1.277. So if I just take 3.14 plus 1.277, I get 4.417. Okay, for the other situation, I'm going to take 1 divided by negative 3.303. Calculator gives me negative 0.294. That's going to be a fourth quadrant angle. Not allowed to use negative, but we do need to know that this is the reference angle. So if I just add 6.28 to this, I get 5.986. Okay, and then I'm going to take, so that's going to be this reference angle. So if I take 3.14 minus 0.294, I get 2.846. Okay. All right. I know this is a whirlwind. I'm trying to make this under 15 minutes. Feel free to stop by my office hours if you have questions.